Part 1 of Section 3.6, Transformations of Graphs of Linear Functions. We start with a vocabulary term, family of functions. Family of functions is a group of functions that have the same characteristics. Usually, we can talk about lines would be a family of functions. We've been looking at lines so far here, but there are other functions. We'll be looking at absolute value functions, and those have this general shape. It could be narrower, could be wider, could be opening downward, things like that. Later on in the year, we'll talk about these types of functions. Those deal with x squared, but all of those are different types of families of functions, groups of functions that have the same characteristics. Okay, the most basic function in a family is called the parent function. Okay, we're going to be focusing on lines here. Okay, so the most basic line, the parent line function, so we're talking lines here, that's going to be f of x is equal to x, or you can think about it as y equals x. What that means is that your slope is going to be 1 with a y-intercept of 0. Okay, a slope of 1 with a y-intercept of 0. In my classroom, I do have the parent linear function. It's up by the clock right above the bulletin board. So next time you're in my room, take a look at that. What we're going to be talking about in this section are what's called transformations. Okay, transformation is a change in size, shape, position, or orientation of a graph. And we're going to be looking at two different types of transformations in this video. We'll take a look at the third one in the second video. Mainly, we're going to be dealing with size, position for sure, and possibly orientation. I don't know if I would consider a shape if we flip it over, like with these absolute value functions, if opening it downward would be a change in shape or a change in orientation. I would probably say change in orientation. Mainly, we're going to be working with size, position, and orientation. Okay, the first transformation we're going to discuss is a translation. A translation is a shift of a graph horizontally or vertically. Key point here is it does not change the size, shape, or orientation. We're just moving the graph either left, right, up, or down, or it could be a combination of those four. Okay, up and right, down and left, down and right, up and left, anything like that. Okay, but the key here is it does not change the size, shape, or orientation. We're just moving the whole thing in one direction. All right, so what I'm going to do, I'm going to make a table here, and we're going to be talking about two different types of translations. We're talking about horizontal translations, horizontal, and we're going to be talking vertical translations. Now, I'm going to be making this chart several times throughout this section, so get used to doing this because it's going to help keep things organized. Okay, for horizontal translations, it's going to be y equals, so our original function, f of x minus h. Now notice the minus h is on the inside of the parenthesis. Okay, we're doing something directly to x. See how this is directly to x, x minus h. What we're doing here is what this does is it shifts the graph. Let's spell graph correctly, ph. Shifts the graph h units left or right. Okay, shifts the graph h units left or right. Okay, so one bullet point there. Another bullet point being, with this one, the directions are going to be opposite. Directions are opposite. Okay, so what this means here is that if I had x minus 3, what that means, normally we think if we take away 3 that we get 3 to the left, or we get 3 smaller on a number line. This actually means, let me get rid of that, 3 units to the right. And if we had, let me switch colors here again, if we have x plus 2, what this means is 2 units to the left. Okay, so if we see x minus 3, that means 3 units to the right, and then x plus 2 is going to be 2 units to the left. Now for vertical translations, it's going to be y equals f of x plus h, not h, it's going to be k. The letter is k. Okay, notice the difference with horizontal, the new number is going to be in the parentheses. The new number in vertical is going to be outside of the parentheses. It's going to be on the end of the original function. So remember, f of x is going to be our original function, and then we're going to add something either to the entire function or to the end of it, or we're going to add it directly to x. Okay, so with this one, with vertical shifts or vertical translations, The k value shifts the graph k units, and since it's vertical, we're going up or down. Okay, if we had with vertical translations, the directions are normal. Okay, directions, and we can put those in quotes, normal. Okay, meaning that if we had a plus, that means up, and if we had a minus, that is down. Okay, so again, I'll summarize this real quick. So with horizontal translations, we're doing something directly to x. With vertical translations, it's done to the entire function or to the end of the function. With vertical, remember, it's the opposites are directions are opposite, and then in vertical, the directions are normal. So if we have x minus 3, that's 3 units to the right. If we have a plus on the end, then that's going up. X plus 2 means 2 to the left, and then if we have a minus on the end, that means we're going down. What we're going to find, and I'm going to add one more note to each column here, with anything with horizontal transformations, so whether it's a translation or the other two types of transformations, anytime it's horizontal, the transformation is applied directly to x. Okay, anything that is a horizontal change is applied directly to x. Anything that's vertical is applied to the entire function. Okay, and that's a key thing to remember, because that's going to help determine whether or not we're going horizontal or vertical. If it's applied directly to x, it's horizontal. If it's applied directly to, or if it's applied to the entire function, then it's a vertical change. All right, let's try graphing here. Let's try deciphering what's going on here. So let f of x is equal to 2x plus 1. So this is going to be our original function. F of x is equal to 2x plus 1. Number one, graph g of x is equal to f of x plus 1. So notice the plus 1 is on the end of the function. We need to describe the transformation from f to g. Now, since the plus 1 is on the outside, that is a vertical transformation. And if it's adding or subtracting, vertical, this is a translation. Obviously, it makes sense because we just talked about translations. It's a vertical translation, and then since it's plus 1, it's 1 unit. And with vertical, the directions are normal, so it's 1 unit up. I'm going to graph these all at the same time, and we'll get to that in just a second. Let's move on real quick to number 2. Graph h of x is equal to f of x minus 3. Now notice this time the minus 3 is on the inside. If it's on the inside or directly to x, that means it's a horizontal translation. The number is 3, so we're going 3 units. The question then becomes which direction. Normally if we think minus 3, that means we're getting smaller, and on smaller numbers on the number line to the left. But remember with horizontal, it's opposite direction. So minus 3 means 3 units to the right. Okay, so we're going 3 units to the right. That's all we need to say for describe the transformation from f to h. It's a horizontal translation, 3 units to the right. All right, let's actually do some graphing here. So let me bring in some graph paper. Let me draw my coordinate plane here. Let me attempt that again. Okay, so we've got our xy axis. The original one was f of x is equal to, let me go back, 2x plus 1. Okay, so let's start by graphing that. So we started our y-intercept of 1. Our slope of 2 means we go up 2 units and then right 1. Up 2, right 1, up 2, right 1, up 2, right 1. Instead of going up and to the right, we could also go down and to the left. So we'd have a point there, we'd have a point there, and then we can make our original line, okay? Slide that a little more. This is f of x, okay? That's the original function that we were given. Let's go back to number 1. We need to vertically translate something 1 unit up. So each point, we're going to take 1 unit up, okay? So 1 unit up, 1 unit up, 1 unit up, 1 unit up. And so we're going to have new points at these markers here. Okay, we're just going 1 unit up with the original points, and then we'll draw our line. This in red is g of x, okay? Do you need to draw these little lines connecting them? No, I'm just showing you that every point gets shifted 1 unit up. Now, for number 2, we need to go 3 units to the right. We're going from f of x again. We're not using the red one, we're going back to the black one. So 3 units to the right. So we go 1, 2, 3 units to the right, 1, 2, 3 units to the right, 1, 2, 3 units to the right, 3 units to the right, 3 units to the right, and we can make our new ordered pairs. Okay, we got those right there. Draw the line. This is h of x. So do I need to see these connecting lines either in red or purple? No, but on the graph I would like to see the black line, the red line, and the purple line. Let's try another one here. Let f of x equal 1/2 x minus 1. Number 1, graph g of x is equal to f of x plus 3. Describe the transformation from f to g. So we got plus 3, and it's on the outside of the function. It's not directly on the inside, so this is a vertical translation. Vertical translation. It's going to be 3 units. And again, since it's plus and it's vertical, that means it's normal. That's 3 units up. We'll do the same thing with number 2 here. We got the plus 2 on the inside. H of x is equal to f of x plus 2. So since it's on the inside, that is a horizontal translation. Horizontal translation. And the number is 2, so 2 units. And since it's plus 1, that means, plus 2, that means we're going 2 units to the left. Remember, directions are backwards in horizontal translations. So let's bring in some graph paper here, and let's give it another shot. So I'm going to draw my coordinate plane here. Oops, let's try that again. Get it on the line a little closer. Okay, the original one was 1/2 x minus 1. So we'll start at -1 with our y-intercept. Go up 1, right 2 for our next point. Up 1, right 2. Up 1, right 2. Or instead of up and to the right, we could go down and to the left, down and to the left, down and to the left. And we can draw our line. This is f of x. Okay, so let's go back to the red. Vertical translation, 3 units up. So take each point and go up 3 units. So 1, 2, 3. I'm not going to draw the lines this time. I'm just going to mark the points. 1, 2, 3. Skipped one there. Be right there. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, you can see the lines are still parallel. Okay, we're just sliding everything up 3 units, and this is g of x. Now, number 2 said horizontal translation 2 units to the left. So now I'm going to work in purple. Take each point and go 2 units to the left. Okay, so we'll just keep marking them there. 2 units to the left with each point. And there we are. There is h of x in purple. Hopefully those make sense to you. We'll keep working with translations and more transformations in the second part of the video, but hopefully there's a good introduction to translations. Now, the second type of transformation in section 3.6 is a reflection, and that is a vocabulary term. A reflection, basically, or what it does is it flips a graph over a line. Okay, usually the lines we're going to be using in this section are the x or y axis. We're not going to see anything other than the x or the y axis. Okay, so I'm going to make another table here. Hopefully I got enough room. Okay, so if we're talking if we're reflecting it in the x axis, so you're going to see that terminology in the x axis or in the y axis. Okay, the x axis reflection is going to be y equals negative f of x. The y-axis reflection, y equals f of negative x. So the difference between the x-axis reflection and the y-axis reflection obviously is where the negative sign resides. In the x-axis, it's out in front of the entire function. So for the x-axis, we're going to multiply entire function by -1. For the y-axis reflection, we're multiplying x by -1. Okay, and what we're going to see here, hopefully, and I'll come back to it, is which one's the horizontal reflection, which one is the vertical reflection. So let's try this example here. So f of x is equal to 1/2 x plus 1. Number 1, graph g of x is equal to negative f of x. Describe the transformation from f to g. So the negative sign in number 1 here is outside of the function, or it's outside of, or it's to the entire function, and that one is a reflection in the x-axis. Okay, so our describing the transformation is simply going to be a reflection in the x-axis. That's going to be our transformation. That's what we're going to do, and we'll graph it here in just a second. Okay, number 2 then says h of x is equal to f of negative x. Describe the transformation from f to h. Now, notice the negative sign is on the inside of the parenthesis. It's directly with x, so this is a reflection in the y-axis. Okay, it's a reflection in the y-axis. So let's go ahead and graph. I'm bringing the graph paper again. Let me draw my x and y axis here. Okay, so the original function was 1/2 x plus 1. Okay, so let's start there. So 1/2 x plus 1. So we start at 1 on the y-axis, then go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 left 2, down 1 left 2, down 1 left 2, and we have our, we have our line here. Okay, so there is f of x. There's the original one, f of x. Okay, so number 1 said a reflection in the x-axis. So I'm going to start with the y-intercept. What we're going to note, or what we see, is that this point is 1 unit away from the x-axis. So to reflect it, if I'm 1 unit above, when I reflect it, I'm going to be 1 unit below. Okay, it's a 1 unit below. This point right here is 2 units above the x-axis. So then when I reflect it, it's going to be 2 below. So this one goes here. This point right here, 3 units above. So when I reflect, it's now going to be 3 units below. Okay, do the same thing on the other side. This point is on the x-axis, so if I'm 0 units away, that means, well, when I reflect it, I'm still going to be 0 units away. These 2 points are actually the same. This point right here is 1 unit below, so then when I reflect it, it's going to be 1 unit above. And then this point right here, 2 units below, when I reflect, then it's going to be 2 units above. So then we have enough points to draw, more than enough points to draw our line. So we can put that in there. This right here is g of x. So notice we flipped it from the, let's say, quadrant 1 down to quadrant 4. That would be kind of a vertical change. And remember, vertical transformations are applied to the entire function. So the x-axis we can think of as vertical. The y-axis, that what we're going to see is that's kind of a horizontal reflection. Okay? It's a horizontal reflection because we're going from here over the y-axis. We're going horizontally. And anything horizontal is going to be multiplying directly to x, or doing something directly to x. Okay, so we're reflected in the y-axis. Now, this point right here is on the y-axis, so when I reflect it, it's not going to move. This point is shared with the original one. Now, this point right here is 2 units away from the y-axis on the right-hand side, so when I reflect it over to the left-hand side, we need to keep that 2 units of space. Okay, so keep going. This point right here is 4 units away, 1, 2, 3, 4. So when I reflect it, it needs to be 1, 2, 3, 4 units away on the other side. Okay, let's pick a different point. How about this one right here? 4 units away. So when I reflect it, it needs to be 4 units away. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. That one's going to be right there. I missed one. This point right here is 2 units away. So when I reflect, it needs to be 2 units away. Right there. I think we've got enough. Go ahead and draw the line. That's a terrible line, but you get the idea. This one here in purple is h of x. So there's the graph of f of x, and then the 2 reflections over the x-axis and over the y-axis. Let's try one more here. Let f of x equal negative 4x minus 2. Number 1, graph g of x is equal to f of negative x. Describe the transformation. The negative is on the inside. It's directly to x, which means it's a horizontal transformation. Horizontal, and since this one is a multiplying by negative 1, this is a reflection. Horizontal reflection, or you could just say a reflection in the y-axis. We're going from like quadrant 1 to quadrant 2, the upper right to the upper left. This is a horizontal reflection, or just a reflection in the y-axis would be fine. You don't necessarily need to write horizontal there. For the second one, h of x is equal to negative f of x. Now the negative is on the outside, which means this is a reflection. This would be kind of a vertical reflection. This is a reflection in the x-axis. Okay, reflection in the x-axis. So we've got our transformations. Let's go ahead and graph them. So let me draw in my coordinate plane here. Got my y-axis, got my x-axis. The original function was negative 4x minus 2. So we'll start here at negative 2. Slope of negative 4 means down 4, right 1, or up 4, left 1. Up 4, left 1. So I got 4 points on my line this time. That's all right. It's a little steeper of a line. Oops, let's try that again. Oh, that's even worse. Just extend it there. Okay, so there's f of x in black. G of x, we need to reflect something in the y-axis. So this point right here was 1 away from the y-axis, so it needs to be 1 away on the other side, so that's over here. This point right here is 2 away, so then when I reflect, it needs to be 2 away on the other side. Clean that point up a little bit. This point right here on the y-axis is on the y-axis, so when I reflect it, it stays exactly where it is, so that stays there. And then the fourth point is 1 away on the right-hand side, so when I reflect, it then becomes 1 away on the left-hand side. So then we can draw our curve. That's a really bad curve, but just go with it. This is g of x. It's a horizontal reflection, or a reflection in the y-axis. And then the second one, or h of x, is a reflection in the x-axis. So this point right here is 2 away from the x-axis. So when I reflect, it needs to be 2 away on the top side. So 2 there. This point right here, we're going over the x-axis, is 2 away. So then when I reflect it, it needs to be 2 away on the other side. So that point there. Let's see, this point right here, 1, 2, 3, 4, 5, 6 away from the x-axis. So when I reflect it, it needs to be 2, 4, 6 away. So it's going to be down there, right here. And then this point right here, let's see, 1, 2, 3, 4, 5, 6 away. So I need to go 2, 4, 6 above, and I'm going to be right there. So it's going to be, whoops, sorry about that. Let's bring that back. Going to be right there. Okay, so let's go ahead and draw that line in. This one here in purple is h of x. Hopefully those two types of transformations make sense. There is a third type of transformation. That's what we'll get covered in the second part of this video. That will be coming up shortly.